Yeah, as you might see, it's actually a kind of an improvised meetup, but we, IOTA Foundation, thought we would take the chance. So it was offered for free. They provided some pizza, and we were like, yeah, why not? Let's do it. So the agenda for today is we are very happy to have Julie on stage talking about IOTA basics, talking about IOTA Foundation, and after that we have Kevin from Highmobility and Anne that are going to present a sneak review of our collaboration. And then we have Sven from Accessec talking about the concept of a talking about the concept of a e-Carwallet and maybe show something what they are working on now, maybe a little bit. And then after we have some time to network, chat, I don't know, maybe until then, is that right? Let's see. Yeah, so my name is Alisa, I think I totally forgot to mention that. And maybe all the foundation members can just stand up and say hello, because we have quite some people in the room. I mean, if you want to, you can just introduce yourself very quickly, maybe it's interesting for the people here. So my name is Alisa, I'm leading mobility and automotive adoption stream. I'm very happy that we got invited by Chris, and we really believe that building such an innovation mobility hub in Berlin makes sense, and we are happy to be like at the forefront of it and being part of it. So maybe if you want to, you can continue.
I'm Julie, everybody. I am the Director of Social Impact for the IOTA Foundation and Regulatory Affairs. So I have to explain all this to the lawmakers. Next.
Hi everyone, I'm Alisa, software engineer at IOTA and doing cool stuff.
Hi everyone, I'm Daniela, Director of Human Resources in IOTA. Did we skip someone? Yes.
Doesn't matter.
Sorry, thank you.
No problem. I'm Regine. I'm supporting IOTA business development, so bridging the gap between IOTA and the industry.
Hi, Steve.
Hi, I'm Anne. I'm a Senior Project and Partnership Manager, and I'll be presenting some really cool stuff later.
Hey, I'm Felix, Regulatory Affairs as well. I actually be explaining stuff to the lawmakers.
Hi, we're I'm the Impact Project Manager also from the scheme.
Hi, I'm Wolfgang. I work for the research department doing technical simulation and other interesting theoretical stuff.
I'm Florian, also part of the social impact team.
I think I'm the last. My name is Jan. I'm a technical analyst with the mobility stream.
Yeah, I'm Janine. I'm working for the mobility automotive team and product manager.
Yeah, my name is Jana. I'm a head of strategic projects with IOTA, so I'm taking care of the collaboration.
Good. So, yeah. I'm not sure if someone has seen so many other people in one room. Yeah, so we are happy to answer all your questions. Also after the meetup, feel free to approach us. Maybe just one question: who, I don't know, who has done stuff with IOTA already? Good. Who wants to learn from scratch what IOTA is about? And who is like, what the heck I'm doing here? Okay, no. Okay, good. So, everyone of you will have something on. And I will hand over to you, Julie. Cool. Thanks.
All right, so I think this is officially the first time that I've spoken on behalf of IOTA while drinking a beer. So that's great, but I don't really know. No pictures. I don't really like Apfelschorle, so there you go. That's my excuse anyway. So as I already said, my name is Julie, and I am the Director of Social Impact for the IOTA Foundation. and regulatory affairs. And what that means is that I mostly spend my time, in addition to explaining what all of this is, to lawmakers and regulators and policymakers, so that they can help us have sound regulatory regimes that support innovation rather than hinder it. I also work with some of these fine folks who sort of introduce themselves here to actually build projects together with governments and intergovernmental organizations to use our technology in real ways, which is super exciting. And I'll tell you a little bit about that. So Alisa asked me to just kind of give the yay food. Now it's officially a meeting. Should we break for pizza distribution or just sort of do it as we go? Yeah. Okay. Feel free to come around, chow down, don't be shy.
We'll help you.
Perfect. Alisa asked me to just kind of give an overview of what IOTA is and the IOTA Foundation and what we do. And this is really kind of ironic because we have a bunch of people in the room who are devs and who have built some super cool stuff on the Tangle, and that is not me. I'm a lawyer and an economist. I don't actually build stuff on the Tangle, but I can explain in basic terms how it works. And if you want to know more, then you should definitely seek out some of our folks who are developers, and in particular, a person back here who I've not met yet. Nice to meet you. Who is from our research team as well. So everybody's kind of basically familiar with blockchain, right? Is there anybody who has no idea what a blockchain is? Never heard of it, just came for the pizza. Okay, so basically we are in the distributed ledger space. We are a different type of technology as opposed to a blockchain. And the core innovation of distributed ledgers really is this idea that data can be replicated in a distributed network, and that a decentralized consensus algorithm helps the network stay in agreement about the current state of things. And so blockchains give us a single source of truth and this immutable, I'll put it in quotation marks, and verifiable record of data. In quotation marks because it depends on how you define immutability. What is the big innovation behind IOTA? So in 2015, the founders of IOTA saw that there are some limits to scalability with blockchain. And one of the co-founders, Sergei Popov, who is a mathematician, proposed an architecture that had what he considered to be better scaling properties based on a directed acyclic graph instead of a blockchain, and that's the architecture that we call the Tangle. So the basic proposition was, when you build a blockchain, you essentially create a classic bottleneck in terms of architecture. You have a situation in which you're having the consensus mechanism. You have a whole bunch of transactions being propagated. They all want to be confirmed, and they all want to be considered to be true and confirmed in the blockchain. And they have to be sort of bundled into batches, which we call blocks, which in different blockchains are confirmed at particular intervals of time. It's about every 10 minutes in the Bitcoin blockchain. And they have certain limitations in terms of the data size, the amount of data that can be put into each block. And then the data is sort of, it is time-stamped and sealed with a cryptographic hash based on an algorithm that is performed, a mathematical computation that's performed by a bunch of people who try and essentially race to solve a mathematical puzzle faster than everybody else. This is the process we call mining in the blockchain world. And the person who solves the mathematical puzzle the fastest gets to sign the block and stamp the block and propagates, sort of sends the solution to the mathematical problem out to the network. And it's a problem that has the mathematical property that it's difficult to find the answer to, but easy to verify once you found the answer. So the best, fastest way to find the answer is to simply randomly guess super fast until you get the answer. And then you show it to the rest of the network, and they all say, oh yes, that's the answer, and you win the block confirmation. In Bitcoin, you get a reward for doing that. So you are rewarded for your work. Proof of work is what we call the consensus algorithm for that reason. And this leads to this kind of bottleneck because everything has to be batched into these blocks and wait for this confirmation, and then everything gets kind of strung together one block on the next, because when you confirm this block, with the solution to this algorithm, the algorithm will spit out a new input for the next computation to be solved. And there's no way to fast forward and guess this computation when this block hasn't, this computation when this block hasn't yet been solved, because you don't have, you have an input missing. So I hope that makes sense at a very, very general level. You have to build sequentially in blocks. This creates a bottleneck. So it can lead to very slow confirmation times, and because you have these miners racing to do all this work to be the ones that get to add the next block and generate the reward of the coins that are minted, you have transaction fees as well. And the transaction fees vary depending upon how many people are mining on the network, how many people are trying to confirm transactions, etc. And that's how that works. So in the tangle, what Sergey Popov thought to himself was, hey, what if we could get rid of this block structure and make it a little bit messier, open up this bottleneck, so that we wouldn't have this problem with waiting for these sequential confirmations. And so he looked at whether you could do that with a directed acyclic graph, which is something, a mathematical construct that's used in lots of different contexts. It's not like the tangle invented in DAX. This is kind of around in a lot of other settings. And essentially what happens in the tangle is that each person, each node that participates in the tangle is its own miner. So you propagate a transaction, you send out a transaction to the network that you would like to have confirmed. And in order to have your own transaction confirmed, you have to do a sort of miniature proof of work to confirm the transactions of two other people who have already sent transactions to the tangle. And once you have done these two other proof of works, then your own transaction becomes eligible for confirmation. And this is kind of a graphical depiction of what this looks like. As you can see, it's kind of messy. This is why it's called the tangle. It's not a nice linear line. It's just a bunch of stuff bunched together. And the arrows are showing that the transactions are mapping to each other in a directional way. This is the directed part, the directed acyclic graph, using a tip selection algorithm. So when you send your transaction, you have to decide which other two transactions are you going to confirm. And so you employ this tip selection algorithm in order to identify which other tips you should confirm. And the way that the tip selection algorithm works is that you will attempt essentially to confirm. This is where you should come up and explain this. You can ask him for the details afterwards. And in fact, do you know off the top of your head the domain of the website where you can play with alpha and set the tip selection algorithm and all of that?
Not by heart.
Not by heart. We can Google it for you if you want to play with this yourselves, if you're interested in doing this. So essentially, I don't have the equation written down here. It took a lot of time to prepare this presentation, unfortunately. But there's an equation that you use when you are selecting which tips you're going to approve, and there's a value, an alpha value, somewhere between 0 and 1. And depending on what your alpha value is that you set, you will either be getting 100% confirmation of things that are already heavily confirmed, or you will be setting a different value of alpha so that you can make the process of your block more random. So you're using a random block Monte Carlo Markov chain, essentially. And you play with alpha to make it more or less random, and this changes the confirmation times as well as the probability of a particular tip getting selected for confirmation. A lot of active research happening in the research team about what the ideal value of alpha should be. Talk to him afterwards. But this is basically how it happens. And as a result, you get this map of transactions that are kind of mapping to each other. These ones have confirmed these ones, and these ones have confirmed these ones, and whatnot. And then when you get to the end, wait, which direction are they going? They're going this way, actually. So, other way around. So these ones are the tips, and the way that we decide which part of the tangle is considered considered confirmed is a notion of heaviness. So the part of the tangle that is heaviest with the most weight of confirmations is the part that's going to be considered the most valid by all the other nodes, and then those that don't have weight and that are not confirmed very often are going to be orphaned into subtangles, similar to how you get orphaned chains in blockchain if it's not the longest chain. Okay, so one nice feature of this is that in theory, if you look at the math paper, more activity means more validation in a DAG setup. I say in theory because the mathematical theory and the real life implementation, as is often the case in any kind of a technology setting, are not exactly the same. And the real life implementation is definitely messier, but in theory you should get more validation as you get more transactions. And that's the idea behind behind eliminating the bottleneck. So because we have no miners, we don't have any fees. So there's nobody that's earning IOTA in order to do this work, this proof of work, like you have on Bitcoin or Ethereum or other blockchains, which means you can send microtransactions, really, truly microtransactions, without having to pay any fees. Now you could say, well, actually you still have to do a tiny little bit of work in your processor to do these two-tip selection, to confirm these two tips. That's true. We've done some calculations on how expensive it is to do that. I think it came out to 0.001 cents or something like that. So it's true. There's a fee because there's electricity that you have to use in your processor. But the nice thing is you can use really small devices. They can be not very powerful devices. They don't have to have high processing power. They don't have to have high storage capabilities and other things like this. So the main challenges that IOTA addresses, like any blockchain, creating trust in the integrity of data, that it can't be altered without it being evident to everybody who uses the ledger after the fact. Zero fees for transactions. You can send them in real time. And it helps us to solve problems like mobility, where you have to collaborate with lots of different actors and lots of different devices in many, many, many microtransactions. So I'm sure you guys will talk about this when you get to some of your notes. So this kind of enables the Internet of Everything. And that was really the vision of IOTA's co-founders, to really bring a distributed ledger that would be deployable for Internet of Things in the world that we'll need. So when I work in social impact, and the reality of my world is the Internet isn't everywhere yet. So we still have 1.6 billion people in the world who don't have electricity. Just electricity. About 40%, only 40% of the world's population has an internet connection today. Around the world, among those who do have internet, not everybody has full access. They might have only censored access to the internet. And so the question that our team struggles with often, and that we're trying to solve in the social impact team, is can new connectivity paradigms help us overcome these problems, so that we can create social impact with this new, exciting Internet of Things world that's coming fast and furious upon us. And so there are a few technologies that we're looking to combine to try and figure out how to make this happen. One is mesh networks. These can be set up in different kinds of ways. They can be set up opportunistically as well. And the key features of mesh networks are that they can be asynchronous. They don't all have to be happening in a synchronized way. They don't necessarily need to have constant internet access or constant electricity supply. They can also run on small battery-powered devices or solar-powered devices. They can carry machine-to-machine messages securely in very small data packets. And they can use alternate connectivity spectrums such as Bluetooth, LoRa, LoRaWAN, radio frequencies, and VSAT. And then the third thing that's a nice feature about the Tangle is that you can also partition the Tangle into online and offline subclusters, and then figure out how to reintegrate the offline or previously offline portions of the Tangle with online portions once you restore internet connectivity. And this is super, super useful for the problems that we're trying to solve in the social impact space. Oh, one more technology that we're looking to integrate with everything is Earth and space mobility. So how do we use satellites to connect up local mesh networks on different parts of the Earth that are not connected to each other. If you want to know a little bit more about some of the technical details of how we're looking at figuring out how to go about this problem, you can ask Alexei here in the front later on, because he is one of the programmers that's helping us put this together, in particular for some solutions that we're developing for humanitarian settings and United Nations peacekeeping settings, where you have people in extremely remote locations, often without electricity and without connectivity, except through these sort of opportunistic settings. So the idea is, how can we combine these technologies, mesh networks, space connections, things, and solve problems that we actually have? And I'll just give one example from our team's work, current work, from the social impact space, and then we'll hand over to the mobility discussion. How do we make climate data accessible? So one of the projects that we're working on actually came out of the Hack for Climate, which took place in association with the UN Framework Convention on Climate Change in Bonn, Germany last year. And we co-sponsored that hack with a number of other organizations. And the winners of that hack came up with an idea to use machine learning based on satellite imagery to predict at-risk areas of the rainforest. At-risk in the sense that they are most likely to be deforested next, based on time-lapse imagery of satellite photos. This is them down here. They built their solution on Ethereum. Boo. But I love Ethereum as well. It's a great project. But they were open to exploring other options as well. And we said, hey, wouldn't it be cool if we could connect the information that you're looking at from the skies or from space with actual information that's collected from the forests on the ground? If we set up a mesh network of sensors in the forest that can do things like measure human activities, microphones, to just see when people go in with chainsaws and start clear cutting, smoke detectors for when people are setting fires, or other kinds of information that will give a little bit more active, real-time data on what's happening in these forests. Because you might not know this, but we, as taxpayers, are funneling huge amounts of money to forest preservation programs and to reward people in areas not to deforest, for palm seed oil, for other kinds of things, especially in developing countries where people don't really have a viable alternative way of making living. So the idea is, let's figure out how to use this data in real time to make this happen. Info from space, info from the ground. And the space data is great, but what they have right now is they get a flyover of a satellite maybe once a year, twice a year, at most 4 times a year, which takes a photo of the forest. And if somebody burns it down in 3 months that the satellite's not there, well, it's gone, and you can't recuperate that carbon sink. So we started working with them and with other organizations that are actually on the ground running carbon sink forest preservation projects. And we are figuring out a way to use this data to create better carbon baselines for the international climate change carbon trading schemes, which big corporations trade carbon credits amongst themselves. And we will create better baselines using the information we get from the forest and from the skies, and make that available on data marketplaces where climate researchers also can track the progress of what's happening in the forest in real time, and people who are in the business side of things can figure out how to better monetize these carbon credit markets. So this is kind of how we work. I imagine that it's similar for your team, but maybe you'll have a slightly different model. Basically what happens in the social impact is that somebody comes to us with a problem, or we identify one ourselves that we think would be really interesting to try and work on, and that we think our technology has a piece to contribute. And we work together with the problem owners to define the requirements, the technical requirements. So in this case, the problem owners are the forest preservation projects on the ground. Not us, as they are the foundation, it's really them. And they say, well, this is what we have out there in this very remote area of Brazil. This is the kind of data that we have. This is the kind of data we'd like to have. These are the limitations we face in terms of the regulatory environment, et cetera, et cetera, et cetera. And then we do sort of an iterative scoping with them, with other partners in our network, people who build sensors, people who work on satellite connectivity, people who do all this other stuff. We try to bring everybody together and scope the problem iteratively until we come up with some ideas that maybe make sense as possible solutions. And then we poke holes at it, and poke lots of holes at it, and sometimes we throw it out and start from scratch again. Sometimes we throw out the whole project and think we just can't help with this problem. But sometimes we come up with a couple of good ideas and we think, we should move forward with these. And then we move it into a proof of concept phase, where we then develop the community, we figure out who's missing from the solution, what pieces of the puzzle are here, we bring those actors in, we go out and find funding for it if we don't have enough funding ourselves. That's Florian's job in the back of the room. And then we figure out how to bring everybody together and create a proof of concept. And then at the end of the proof of concept, we really want to stop and take stock and evaluate, did this actually solve the problem that we set out to solve? So it's important to think about in the proof of concept design how we build in evidence tests so that we can gather some empirical evidence along the way about whether or not our solution actually is solving the problem. Because we want to have quantitative data at the end, not just a qualitative impression, but quantitative data to tell us if we did or did not solve the problem. And if we did, then we try and scale it, and we make it a pilot project, we test it in the real world, we take it not just from the lab, but to the Amazon, and we scale it and see if it works. So that's basically the social impact journey. Let me tell you just a brief word about IOTA Foundation, and then I'll hand over to you guys. So the IOTA Foundation is a global team of folks. You've met most of the folks that work in Germany now here in this room. There's not that many of us here, maybe 17 or 18 in Berlin.
19, yeah.
Okay, in Germany. But we have about 80 people worldwide in 70 different countries. It's really, really, truly a global initiative. I've been involved with IOTA